Okay, so let's continue with the cool compiler today. And basically, as you already know, we did all the tokens in the last few episodes. Basically, we got like all the tokens that are available in the cool language. And now we should go ahead and implement the AST, basically, like the parser. We take these tokens and we need to convert them into a tree structure, and this tree structure is better to find the errors in our code, and then uh, to be honest, I don't know if it's easier to get instructions, but I think it should be like you know that you have an if, or you know that you have a sum or something, and yeah, basically it will be easier to get those instructions done, right? So we like in the manual we were around here, I guess. So the next part would be the syntax, right? And this is the specification of the syntax, how a program would look like. It's like a program is a list of classes, and you get the gist of it. So yeah, basically we need to implement this part, right? Like getting the all the classes and all the functions that we have in the classes then, and yeah, it should be fun to try to do. Yeah, I was playing around with again with GPT. Not really that great. Like sometimes it can get like the errors. Like here, for example, it got it, but sometimes it misses like stuff. For example, here it missed the semicolon after this thing. So yeah, I mean, sometimes it works, sometimes it doesn't. It's a hit or miss with ChatGPT on Lexing. So yeah, I mean, let's go ahead and focus on the C version. And yeah, I think I added a few tests, yeah, for the parser. It's basically the ones that I had initially. So we need to display the tree structure now. That's good. And for the Lexer, what I thought was, well, um, usually in the Lexer you don't show the errors, you just get a token and that's it. So what we are gonna do actually in the Lexer is just get the tokens and display them. And inside of the parser we are gonna look through each token, and when we encounter an illegal token, that's when we are gonna display the error message. So we are not gonna display them uh, like we did last time. Like we did that just to play around and see error messages, right? So now let's move that logic into the Lexer where it should actually be. And yeah, I mean, so like still works on the Lexer tests, but we now have to add the parser. And I think for, I mean, we can open new link here. For the parser, I think I added minus sin, like syntax analysis, basically. So let's add in our checker here this option. Interesting. I mean, I would put this into like, you can have a function usage, and sure. So we can say usage instead of having to do that. Anyway, so now we can call the checker .sh. If we go with help, it says we can use syntax, but it doesn't work because we don't parse that yet. So let's go into main, and let's add the option to have like syntax analysis. So it should be S, parse the input file, basically. Well, I mean, it's more like show the result of the lexer or show the result of the parser, but yeah, so this was just displaying the tokens. So we just need here, wait, yeah, we have the, so we have unsigned, we get a thing, and this should be like to do, or like show the parse tree, and then we just return. So right now we don't do anything, and let's say that we are gonna have something like this. Parse the tokens or something, and yeah, we're gonna pass in just the list of tokens, so the array, right? I mean, we could even just send the value, but and it's gonna be like parser run or something, but right now we don't have it, so let's just do this stuff, and now it should just fail because we don't output anything. So yeah, for the parser, let's see, I guess it's similar to the lexer. Yeah, so for the parser, I guess it's gonna be similar to this file. So let's do parser.h, and here we have if not defined parser h, we define it, and yeah, whatever. So for this thing we are gonna need some kind of parser run function, and here we need ds.h. Yeah, and I don't remember if I already said that, but for ds.h, like the best way to actually handle it was to have this ds.c file and just put this here, and now like everywhere where we include ds.h, we no longer need to um, define like the implementation because we already have it in a C file. So like this. So we're gonna take the tokens, right? But now we need some structures. So we are gonna need struct. I mean the parser could be like something private, like we don't really need it. But program, on the other hand, should be like an AST node. So AST program, or should it be program node or something? Program node. Yeah, I mean, I have no idea. But for this program node, we are gonna need a list of classes, right? At the list one, here it says. but it's gonna be just a list of classes. So yeah, basically I think we can say class node like this, and here let's do dynamic array. Now this dynamic array doesn't really care about the type from inside of it, like it can be anything basically. So we have two options here, doing something like struct class node items and using the DA append and stuff macros, or using something more generic like DS dynamic array, which uses void pointer. But I mean, I think this is better. Although, yeah, even the other option would work. I don't see why not. But yeah, that's like a preference thing, I guess, because here we can say classes and we can access the classes like this. So it's not called items, which would be pretty weird in this. But at least you would know by the type what items means, right? So yeah, I mean it's like two options, right? Which one is better, I guess? Yeah, that's a good question though. Then for the class, we need like the type. So we are gonna need a string for the type, a string for inherits, which is optional. So it can be a string or null, basically a char pointer, and a list of features. So yeah, I mean, I'm like really wondering what would be better here. I think I'm just gonna use the, because the other thing for the macro is that the macro can actually just panic and crash. But I guess if you fail to allocate the memory, like, is there even a point in continuing running the program? Or I mean, it's just GG for the program. So that's the only thing, like using either the dynamic array, the generic one, because it would be really nice to be able to say something like class node, right? Like delete the type, but you cannot do that. Well, I mean you can when you run the init function. The init function takes in the item size, but yeah, I mean let's keep it like this because it's easier. Um, yeah, it's pretty much really easy. So we have char pointer name, right? We have the name of the class. We also need the inherits. So let's also add here char pointer superclass. Why not? Oh yeah, and another thing I did since last time was to just add, wait, somewhere like here, was to just add the position inside of each token. This would be helpful on error messages, right? Okay, so going back to the parser, it would also be nice to have the position and stuff here. So is it really a char pointer or should we use a token for it, right? like, should we use the token here? Because the token has the literal value, also has the type, and the position. So yeah, I mean, I think would probably make sense to use the token actually. Yeah, let's use the token. So let's include lexer h, and here let's say struct token, and let's use pointers, just so we can say null and stuff. So struct superclass. Or I mean, what would be the other option? To have a class node, inherits, and to keep the position on each stuff. I guess that could work, because it's a bit annoying to keep the token here. Like, because we only need the name, because we know it's a class. We don't need a token type, but we also need the position of the thing, because if the name, let's say, is int, for example, it's not valid, so we are gonna need to show an error, and the position should be the name. And if you have an error for the superclass, then you need to show the position for that. So yeah, actually maybe we can have a node info structure which has but I'm just thinking what happens for plus. Like, plus cannot really show an error, but one of the operators can. So maybe struct uh, a node info, for example, could be something like char pointer but I think that for integer we are going to keep numbers there. So I mean that means we cannot really use the token anyway, so it is what it is. Let's just keep char pointer value, and maybe position. Would that make sense to have a node info like this? And basically that's, yeah, probably it makes sense to just have node info, right? But then I'm thinking, what happens for numbers? But we can still keep them as strings. Like, we just validate that the string is like the number is fine, and we keep it as a string until the intermediate language or until the optimizations. Would that make sense? Let's see. Maybe there is something interesting. There's nothing. Yeah, I mean, I'm just thinking, would it make sense to keep the values as strings until optimizations or until something that requires you to change them to int? I guess we'll find out. Let's keep it like this. So the easiest thing now would be to have here the struct node info, And let's say we're gonna keep things simple and just not do pointer here. And basically, if the value is missing, then it means that the node info is not node info, right? So then we're gonna have node info for superclass, and yeah, basically if the superclass dot value is null, then we don't have a superclass. So that's the idea. And position doesn't matter, it can be 0. So yeah, that's how I think about classes, right? So let's see. Let's look into parser 01 class. So this one we should be able to actually parse this, right? So we can actually even start on creating the parser itself. So let's go ahead and do parser.c. Here we are going to include parser.h, and yeah, we are going to need something like this. And what we need to output is the program, right? We need to output the program. So that's one thing. I think that if we have errors in the parser run, we cannot really build the program. So that's another thing. So yeah, let's see. I mean, probably we are gonna need the file name just to show the errors nicely inside of the parser. That's something we can add. So const char pointer file name. Anything else for the errors? I don't think so. I think this should be enough. Oh yeah, and in lexer.c I have this thing which is commented out that is used to print errors. So maybe we are gonna take this, but not right now. So how we are gonna do this thing? We have the list of tokens, we have the program. Yeah, like it's pretty I guess going like straight through the tokens one by one, and depending on which token we are at, we are gonna go into, let's say, a depth or like breadth first search or something like that. So we have, like, since we are building a tree from a list, it's gonna be some sort of TFS or BFS. And yeah, so if you think about it, I think it's DFS, because we go into the first class, then we take all the tokens that create that class and all its features. So yeah, it's gonna be a DFS in some way. So let's take a look. So first things first, when we do parser run, we need to initialize the program. So let's also maybe include ds.h. We already have it because it's in here. So let's do ds dynamic array init. Right, we don't have it. ds.h, ds dynamic array init. We have it. Interesting. Maybe it's the, yeah, whatever. So here we need to provide the size. Let's go into parser h. I already forgot the name of this thing, so it's class node. Should be node class. I mean, doesn't matter. Yeah, so it should be class node like this. So we initialize the dynamic array of the program. I mean, pretty weird. Program classes. Yeah, like this could be. We don't need to make it a pointer. Here we can say the address of it. Although this, no, let's keep it here because why not? Let's keep it there. And now we should have some private functions here. So the first one would be static void, and like the idea is, like right now we assume that the first token is a class basically, right? So is class, right? Like this is what we need to have inside of the dynamic array. The first token is the word class. So because of that, we are gonna have a function that parses class. So it's gonna be a static void parser class. And yeah, maybe we can have a structure for this thing. So what am I doing? So we are gonna have a structure parser which needs the file name, const char pointer file name, just for error handling, the dynamic array of tokens, and I think it also needs the position, so unsigned int index, where we are at. Right, so let's create struct parse. Let's create a parser, and let's say that parse class takes in a struct parser pointer parser, and it should also take a class node pointer to a class. Oh, it's so nice to be able to write class and not have it go mad mode. So as I said, we basically have to assume that the first token is of type class, right? So what are we gonna do? Is just while parser.index is less than here I would just say parser.tokens.count, and just to make it more visible. We need to call to parser class. So struct class node class, and let's say that actually this thing, I think it should be int, like show the error in case it was an error, because we cannot put null in a class. That doesn't make sense. So it should be int though. Like if we had an error, then it should return 1 or something. So we have the class, and now we just need to call. So yeah, I don't even know if we get an error, we shouldn't really stop. We should continue with trying to parse further. But it's like how to do it. Like if we get an error, should we handle that error inside of parser class or inside of this while loop? And let's do another thing. Let's do static int parser program. So this thing should be a struct parser pointer parser and the program. And let's not do that yet. Let's have this thing here. And yeah, we are just gonna do this, just parse the program. I wonder how it got to the conclusion that it needs to free that. It's pretty strange. So we just return the result. That's what I think we have to do. Well, obviously we could check if the index is not correct, but for the first part, let's try to assume that all the stuff works, right? Let's not get into errors yet, because it's gonna suck. So yeah, to parse the program, we need to iterate while index is less than count, right? While the parser index is less than the number of tokens, we have to iterate. And here the idea is that we are gonna do parser class on a class, right? Like we assume that the next token is a class. At the end, we return the result. And here comes the question. If we find an error, I think we should advance until the next semicolon. Like that would be what I would do, to be fair. And after that, we try again. But we cannot add the class into the list because it's not really valid. So we somehow have to switch into bug mode, but I don't know, like if result. Let's do another function here, static void advance, or like parser. I forgot how I was calling it, like parser it's more like when you try to come back from an error. What I mean, how to say to coming back from an error in parsing. I think it was recovering. Yeah, because I remember like recovering in in Haskell. It was like parsec or something, the parser, and it had this recover function. When you are getting an error, you can do something like recover from the error, and basically I think you can just go until parser recover, and we should go. Wow, I think it's really cool that it found it. So yeah, the idea is while we can, well, though recovery can fail though, right? Even recovery can fail. That's a good point. So maybe it should be an int parse recovery, and if we find semicolon, I think we should just return 0. And if we didn't find one, we return 1, like, oh, it was an error. So we need include lexer for the tokens. So yeah, basically this is parse recovery. When we fail on something, we have to go until we find the semicolon. So yeah, here we take the token, and if the token is semicolon, we are good. I think that's something. So in the parser program now, if the result is not equal to 0, so it's not valid, I think we should do recovery and then try again. So parser recovery, but I don't know if we care though about failing in recovery. Like if recovery fails, it's gonna be just because we reach the end. That's the only reason we fail, because we reach the end. So this is gonna try to recover. Then when it's gonna go back to the while check, it's gonna fail, or I mean it's not gonna pass. It will have to jump out and go to return. So yeah, I think this should be good. And obviously when we also show the errors, here we have to do show error or something, I don't know. So that would be this thing. So yeah, then for parsing the class, now we reached the interesting stuff. So we have the parser. Okay, so parsing the class. I think we already have the structure, so we just need to fill it in. Let's do int result equals 0. Yeah, so I'm just thinking again, like if we fail to read the class, yeah, like this is what's a bit unclear to me. Do we try to recover in this function or outside of it? I guess it doesn't really matter. We'll see what happens. So let's try to just go with it and say something like parser index. So we just need to check the current token. So let's do something like token. We are going to reuse this thing. So we have the token, and we need to get the current token. So do something like dynamic array get the token. If token type is not equal to class, we fail, right? But I think we can have a function that gives us a token on the parser itself. So it should be something like struct or should be something like static int parser next, and yeah, basically here it gives an error and here it gives us the token. So now we can say something like a parser next, right? Then here we get, if you don't get class, then it's an error. Then after that we need to do next again, so we do another next, and we have to check that token type is not equal to class name, and we return 0. So now we can actually go into parser.h. So now we can actually define the node info. Right, so let's do class name. We can do something like class arrow name dot value, and this should be equal to token literal. I think this should work. And the position should be equal to token dot pose. So why not just rename this to pose then? Okay, so we have that. Then we do another parser next, and here we have two options. So one of them is finding a squarely brace, and the other one is finding the inherits keyword. So let's say if token type is lbrace, is equal to lbrace handle class body, right? Then we have what? The obviously probably a return here. So it's gonna be a return, I guess. I mean, let's just have it. So static int parser class features. So they are called features. So it's gonna be something like this. Let's delete what's inside of this thing. It's gonna be something like this. It's gonna return 0 for now. So yeah, we don't have yet the features. Although yeah, it's strange. Nah, whatever. So we are gonna say that this thing should do a return at some point, like after it finds the R brace. Alright, so it's gonna be a return directly. So if token.type actually I think it's easier to say if token type is equal to inherits, then it means like this is optional. So it's not really, oh, then it's an error if it's not there. Alright, but now we need to do parser next, and if we don't find the class name, then it's an error. Right, so here we have like what, superclass? Yeah, we initialize superclass, and we do a parser next at the end. Perfect. So then, yeah, we handle the class body, and after we handle the class body, we have to do a parser next, and if we don't find an R brace, it's over. It's GG. And then we do return result. So we had result. We can do a return defer. Then return defer 1. We can actually just return defer 1. And have here defer, just because it's a bit easier. So yeah, for now we read the first token. If it's not class, it's GG. Then we have to read the next token. If it's not a class name, again this is something's wrong. So we need to put errors here as well. Then we read the next token, and if we find an inherits, which is optional, we require to have a class name, so we have to do parser next again. We initialize the stuff when we can. Another parser next because we have to skip the class name, and now we should find an L brace, which is mandatory. So if which is mandatory. So this should be if we don't find an L brace, we return defer. And after that we have to handle, oh, that was good, handle the class body. And at the end we have to find the R brace. So I mean, what can I say so far is that it's clearly easier when you use like syntax generator or whatever it's called, where you just write down this stuff and it generates for you this code basically. Like, it's much easier. Like, I'm not really sure how that it's implemented, so that's why I wanted to do it, just to figure out by myself how you can build this AST. Because I mean, after that it's too easy, in my opinion. You just get the AST and like you are halfway done basically. If you use something like, I don't even know how it's called, NTLR. Like, if you use this thing, it's I mean, it's too easy then, but like, you waste a lot of time by doing it manually, so it's also that. Okay, so now we actually build the AST for the first test. So if we go to main, right, we can actually create, here we have the tokens. Let's include parser. So now we can have a struct program node, which is going to be program, and let's do something like parser run, which I mean sure requires the file name, but that's just because we want to be able to print errors. inside of the parser, and we also need to give it the pointer to the program to write inside of it. And yeah, basically if this is not equal to 0, then we show that message with printf compilation halted, I think it was. Yeah, compilation halted without anything, and we return defer. So this is what happens when parsing doesn't work. Right. Okay. So that's that. Now, sure. Oh, what I noticed though in parser.h, I mean, we allocate memory here, so it's gonna be good to have a program node free function or something, because otherwise it's gonna suck to deallocate memory manually. Like even the free function is gonna be like a DFS, so bad. Yeah, I mean, so far freeing the memory isn't hard because we have just this dynamic array, and this is the only place where we allocate stuff. These are obviously it's gonna follow to have here the dynamic array of features, which is gonna be interesting. But let's go into main, and for the parse tree, like you saw, I think in the ref, we have to show program, then it's what, two space ident for the tree, and then the, yeah, should be not that bad, but I would prefer to not have the like, what I was thinking is maybe have another file that does that printing on the program, so something like stprint or something. But since it's gonna be really small, let's keep it here. So we are gonna have a void function, and it's gonna be parser print 3, and we are gonna get program node like this. Then we are gonna go through the classes. So yeah, let's do it in a better way. So then we're gonna have a static void function, and it's gonna be for program. So program print, and it's gonna take the pointer to the program like this. And what I'm also thinking is unsigned int indent, and here we're gonna call it like this. We are gonna need a static void print class. Let's see again. So it's gonna be class, and then all the stuff is gonna be indented below it. So we're gonna do printf, yeah, like, is it really? Just that easy. Then we need to print f in the same way. %s indent class name value, the super class. Well, here we need to do a \n. So this should be the same thing. And to do the other part. And for program we need to do printf, and here we need to do this thing and then program. And for all the classes we need to increase the indent by 2. So this is gonna come, I guess, it's gonna come in this code right here. And now in main, in the real main, let's do parser print program. Something like this. So let's make, and now let's syntax analysis, checker, tests, parser, and let's see the first one. Great. Okay, let's do some debugging. Let's do, okay, so in parse program, parser class, let's print f here, token type, class semicolon end. Well, end, that's good. Class semicolon on the other hand, that's not ideal. So semicolon is good. Here we also need to parser next, and we need to do a semicolon. I think here we need to do a semicolon, and that should actually make it work. While should we just remove the end token? What should we do about the end token? Because the end token is pretty much useless, right? So in main.c, right, like the end token is pretty much useless. So just to make things easier, tokens.count should minus equal 1. Like we just remove the end token because it's not used. Okay, so now we get something. We get program. But then let's see, printf %d. How many classes do we have? 0 classes. And that's really, oh, we didn't add it. So at the end we have to just ds dynamic array append or something like that. So we actually have something, class A. Here it's not null, so if we find inherits, then we set it like this. And I think we should set it to null here. So class super value equals null. So that would actually make it not show it. And we need more identity on classes. So let's actually have define ident size is gonna be 2. Here, indent size, and this thing should be indent size, because what if you want bigger indent? Oh, this also needs to be indent size. Like, this is gonna be so much easier to change to, 3 spaces indents. See, it's easy. So yeah, this is a good start, I guess. We get the, let's do a diff on checker tests parser 01ref. It's the same. It is the same. Let's do 02cl, and this doesn't work because yeah. And I mean, should we, like, no, I mean, we shouldn't handle errors yet. But I'm curious to see what's inside of the file. Well, it's just some features. Right? The features. If we take a look, features are actually either function declarations or they are attributes or something. So they are attributes in this case. Now this is a bit interesting because, again, I wish I did this in Rust. I'm just kidding. So what's gonna happen here is we're gonna have a dynamic array for methods and then dynamic array for attributes. Wait, did Copilot just save me? Because I was thinking, let's have a single dynamic array. That would be so strong, it would be more fun in my opinion to have a single array. But 2 arrays, that's even better, because we can keep the methods and attributes separately. Like, why not? I was thinking to have like then a single structure, but let's go ahead and have only attributes at first, because like building on the tests, like doing TDD it's not really TDD, but you get the point. I mean, is it? I mean, it's TDD basically, because we are trying to make the tests work. We have the tests, but we don't have the code. It's basically TDD 101. So the idea here is to just pretty much define a new structure for the attribute. So let's do a structure quick like test. Do we do type def on these things or not? Because now is the moment, because we don't have that many structs. Let's do type defs. Let's do type def node info. So now I can do this. And here we also do type def. It's harder to do type def after you have like 100,000 structures. So let's do this thing. It's easy. Parser.c. It's already. I mean, this thing can be neutralized. This thing too. And this thing. And I think that's everything. Probably this stuff. Well, let's go to the top and do search for struct. So it looks good. And in main, there's just the program node. And I mean the token, which to be honest, I don't care about it. But I mean, here there are too many things, so let's do type defs. Type def struct attribute node. So it's gonna have the name, the type, and maybe the initialization. So it's maybe an expression. We are gonna see how we are gonna do this because the expressions are gonna suck. I'm just letting you know because, well, don't know yet. Maybe they are not gonna suck. Who knows? Maybe it's gonna be easy. Maybe it's gonna take months. Hopefully not to solve. So where were we? Inside of classes. So we have to handle the class body. So as per usual, let's do something like, here we did parser next. We are not on inherits. We were on lbrace. So currently the token is lbrace, right? We might want to do parser next again, and then have maybe a do while loop. So do we want a do while loop or a while loop? Let's do while we don't encounter an lbrace. Though if we look at how we did it here, we just looked at the counts. Right, we didn't really care about the I wonder if that's the best way. So if index is less than, we just blah blah blah. If it's a class. Well, I think, I'm not sure though, like we could have a do while in here. Let's go back to main, let's see. And let's not really remove this end token, let's keep it. And here let's actually do struct token and then have a parser next first. Let's have a parser next. And then have a do loop and do while token type is not end, right? So let's do that. And then we have the class node, and in here we do a mandatory class, basically. And so this thing works by reading the first token, so we actually, no, I think it's better to do the following thing. We do parser class, we read like the first token, its class, it's Gucci, we add it, and then we read another one, or we don't. That's the question. So let's say this token is a semicolon, then we go back. But let's say, let's think about it. So we try to read a class, right? So it starts with class, blah blah, it ends with semicolon. Then what if we have just a peek, not really a next? Because pretty much we just need to peek into the parser and see if the current token is end. So let's go ahead and do a static int parser peek, and it's just gonna give us the current token. So let's do parser peek. So basically we do a dual loop. We have to read at least one class because that's in the spec. We read at least one class. If it's failed or whatever recovery, we add it to the classes. We have to pick and see the current token. And if that token is equal to end, we can stop. I think that's good. And if that token is not equal to end, it will go again and probably fail or something. So then for the class body, we can do pretty much the same idea. Does it have to? I mean, it can have zero stuff. So let's say while the token type is not equal to air brace. So basically here we read the next token. This can be L brace. If it is L brace, we skip it, go to the next one, and after we got to the next one, if it's R brace, we stop. If it's not R brace, we can do something else, like try to read the attribute. So try to read the attribute, right? Then when we are gonna get to the last R brace, it's gonna stop. So we don't need this thing then. So here, for example, something like this, just to make it work for now. So goes until the R brace, doesn't care about anything, and then it needs to find the semicolon. So let's do make, and let's try to run 0, 1 again. Still works. And for 0, 2, I think this is gonna also work because it's gonna skip the stuff from here, but we need to handle that thing now. So if we look again in this thing, we need to create, oh actually we also have to initialize the classes, so class arrow attributes, we have to initialize this thing. So let's do ds dynamic array init this, and size of is gonna be attribute node. So we're gonna have attribute node in there, which is just the name and type. So then here we just need to check if we find an identifier. We have to I think we can have some attribute node like this. So it's going to be similar to this one, and then we have to parser the attribute. So where is it? We need something like this, parser attribute, and here pass in the attribute, something like this. So we have to parse it. Then this could be parser pick actually, because you know this is gonna skip the entire attribute. This is gonna skip the entire attribute plus the semicolon, obviously, and after that we can pick. So that's what we have to do. And if the result is not 0, we have to do recovery first. So it's exactly the same thing as here. Oh, and obviously we need to add it when it works. So we need to add in the class attributes, we need to add the attribute. So now let's go ahead and do the parser for the attribute. So let's have a static int parser attribute. It's gonna take in the parser and the attribute node. Int result equals 0. Int result equals 0, and at the end we have to do the classic return defer like this. So yeah, actually need to have something similar. So we also need the token, obviously. The token parser next into the token. Then we need to find an identifier. So ident like this. Yeah, if it's not an ident, then it's over for the guy. We take the value, the position, yeah. We have to parser next, then we need a colon, like here, then we need the type, so again a parser next, type, if we find the type then it's like this. Well, this should be class name actually, so that, and then we have to do a parser next, handle init, optional, and after we get the optional, which might be or might not be, we don't really care, we need to check if the token type is equal to semicolon, and if it's not equal to semicolon, how we did it here, was it the same thing? Yeah, it was the same. So if it's not semicolon, we just return defer, and otherwise everything was good. So Actually, let's put this one here. So we're gonna have to do this at some point. So let's see. I'm not sure if oopsie doopsie. So let's see here. Let's print f %s, whatever the token literal is. I really don't care. It's x and y. That's good. So parser attribute should work. Printf. It didn't get here. Oh, so that's because we actually did next. We have to pick here. We have to pick. And if we found an R brace, we still just picked. So we have to parser next. Well, let's see what happens on 0, 1, for example. It fails because here, if we print f the token type to string and token type, this should be the closing bracket, right? So we need another next at the end, maybe something like this. So first one still works. 0, 2 now works. And yeah, I mean, the idea is let's just pick here. If we find I mean, it doesn't make sense. Oh yeah, it actually makes sense. It actually makes sense because well, yeah, it should be a like a while loop until we find the R brace, because these can be, or like, doesn't really matter if they are there. Okay, anyway, so that's one thing. And then in here we just read the stuff. So let's do class print, and then for dot count, let's just try to print them something like this. Let's see what this shows. Attribute, I don't know how it should actually look like. 0, 2 ref. Wait, really? Something's weird, but it's actually it actually works. So if we do checker, we should get at least 2 tests, right? Yeah. Oh, and then oopsie doopsie, it failed. But we get the 2 tests. That's I think that's good for now. That actually makes sense. And I mean, probably we have to move this thing somewhere else because it's not really a good place for it. And yeah, the other stuff is pretty much fine. So we'll have to do more expressions, like more parsing in the next one. So yeah, until then, that was basically all for today. See you. Okay, so actually let's continue. I just had to, get a sick chest pump, and now I'm again ready to work on some cool syntax because yeah, I mean, why not? Let's finish the features and maybe the formals, like let's add functions and stuff, and then expressions will be a bit more difficult because I mean, this thing is not difficult, or like the while loop is not difficult. like the idea of the while loop is pretty easy. But what's a bit difficult is complicated expressions where we have this precedence order, right? Yeah, because I don't know how to parse right now. I don't have a logic, like an algorithm on top of my head to how to parse mathematical expressions. Like doing no, it's infix expressions, Wikipedia. Like this is pretty easy to parse. Or is it like, no, this is the, I guess, prefix, is where you have the operator and then the terms. That's easy to parse. But the one where you have the plus in between is a bit more difficult. So anyway, we won't do that right now. We'll just look at what we did so far. So we have the peak, which is more like the current token, the next, and the recovery, which just goes until semicolon. So these are the building blocks. Okay, let's see. So attribute is called in here. Let's go to parser program, right? So basically here we have parser class. If it failed, we don't show anything, I think, if that fails. But what if recovery fails? I think we don't show anything even in that case. Like it's gonna show the error here probably, so. Okay, then we do what? DS dynamically append, we append the class. Here we pick again, take the current token, but recovery might get us like too far maybe. So like, yeah, maybe still keep this condition here because it might still be required. Well, this would increase the index over the limit. Doing parser next. So yeah, this could actually not be really right? Because of parser recovery. So maybe we have to change parser recovery here and have something like, let's put a token outside. First of all, let's pick, right? Let's pick the parser, get the current token basically, and while token type is not semicolon or end, we can do next basically. So it's like we look at the current token. If the current token is not a semicolon or end, we can go to the next one. And if we find an end, we stop. But if we do peak again, we're gonna be on the next one. Because next gives you the current one and then increases the, so it doesn't really work. Because like if we find a semicolon, then we want to skip it in recovery. But if it's the end, then we don't really want to skip it. Should we put maybe a condition like if the count is larger than, or like the index is larger than the count, and basically stop and not go over end? I mean, the other option would be maybe to have a real peak function that looks one ahead and changes to current or something. We have the current one, which gives us the one that we are on, and peak gives us the next one. And we have to check that the next one is semicolon, basically. So while we are not, so let's say here we put end, right? So we look at the current token. Actually, let's change this one to current, like this, the current one. And if the current one is not end, the current token is not end, right? If token type is semicolon, okay, so if the current one is not end, if the current token is not end, we want to go to the next one. So let's say, I mean, I guess it's easier to just draw and think about it. So basically, let's just make it black. So let's say we have like a token X, doesn't really matter, a token Y, and the end token. Right, so let's say we are here on this one. So it returns this thing inside of token, inside of this variable, and we advance the parser on this thing. So it checks if it's a semicolon, and it's not, it's an X. So it goes again, right? It moves it here, and it has to check this thing if it's a semicolon, and it's not. So it doesn't break, so it has to go again. But then I guess here we need to take the current one. So basically the idea is, let's see what token looks like. So first token will be X, right? Then this passes, so it comes here, it moves the pointer there, but first, yeah, I mean token remains X. Okay, we check if it's semicolon, it's not, so we move to the next instruction, which is current. So token becomes this thing, it's not end, so we go again. We move the reading position here, but the token stays Y. It's not a semicolon, so we move to the next instruction, which is current. We look at this one, it's end, so we stop, we don't move the pointer anywhere, we keep it on end. So now what happens is let's see where was recovery, so it's in parser class. Okay, so we have it in multiple places, right? So we have to change a bit how parse recovery, like how we use the current and next stuff. So let's go to parser program. Here we try to parse a class. Then if that fails, we need to do parser recovery, which will move us, in the worst case, we'll have the parser position on end, if not on the semicolon. So then we have to do this thing, then we have to take the current token, and if we find end, we stop. That's it. And if it's not end, we go again. So I think parser program is fine how it is. Let's go into class. Then let's say that this thing fails, right? This thing tries to read class, but it cannot really be on end, because if it were on end, although yeah, it can, because it can fail here. So I think it's better here to do parser current, not next, and do next just if we find class, right? Like we take the current one and we advance the parser just when we find the right token. So maybe even better would be to change these functions a bit. So this will stay like current, and the other one will be advance, and advance won't take a token as argument because we don't need it. We just need to advance the index, and that's it. Basically current will take the current token and advance just moves one step forward. So in recovery we take the current one, then if it's not end we advance the parser with one position. Yeah, we advance it because advancing it doesn't do anything basically. We check if the current token was semicolon, and if it was, we stop, right? And then we just take again the current one. So basically here when we say advance, it's not really correct. We have to advance just after we make it work, and here we need to do parser current, which is better I think. So we take the current token. If it's not ident, we are gonna have to do something in defer, and we are also gonna need to do maybe have like a function static void parser show error, and we are gonna take the parser, maybe a message. Okay, and we should, well, I mean the error is like either unexpected token or because of an illegal token. So yeah, I mean, why not just have error? So we need current to be available. Okay, and inside of lexer.c we had this commented out function, which we can reuse now inside of here. So this should actually be a bit different. So it's gonna be parser show illegal. Okay, let's put it maybe here. So this is gonna get, well, yeah, let's leave it commented because we are just gonna use it. So here, parser show error. Well, we can have a message. Well, we don't need a message. Parser show error on the current token, basically. So we have two options. We take the current token, and we have two options. If token type is equal to illegal, then it was an Alexa error, and on the else case, this is like unexpected token, pretty much, I think. So yeah, let's try to scavenge this thing. So we take this. Do we have a util? Okay, so Lexer, this should be, we actually need the buffer to convert the position to line column. That's a bit annoying, but it's not really a huge issue. So here I would say like parser, and we need a buffer, which I mean it's like we could save inside of the tokens the line and column, but I like more to have the position. It translates easier between position and buffer, you know, so that's something. So here let's say token.pos and this thing. So we don't have this function. Let's include it. Include util.h, and yeah, the only thing that we're missing is the buffer from the parser. So let's keep the buffer here. Let's have it. It's a bit char pointer buffer. It's a bit annoying that we need it, but yeah, I mean, let's have it. Why not? Char pointer buffer. So here when we initialize the parser, we also give it buffer equals buffer. And now in main, we just have to also pass the buffer here. So it's what it is. It really buffer? Yeah, it's buffer. Yeah, I don't really like this, but don't really have an option. Anyway. Right, like. Okay, so now we can get the line and column. So we can try to reuse most of the stuff from here inside of this if statement. So here we have parser file name. This is token literal. I'm just gonna make it compile, you know. Basically, that's the only goal in this chunk of code. But yeah. Yeah, I mean, maybe I'll try to do by myself the line and column inside of the token. But yeah, I don't know. And for unexpected token, it's more like, again, if you have the file name, let's see if is it the same. So it's if the parser file name is not null, then we can print. Then yeah, we can print the file. If the token literal is not null, does it really matter? So syntax error should be like unexpected. Shouldn't it be like unexpected and then the token type? I think so. Let's delete whatever ChatGPT, Copilot, whatever generated, and have here like unexpected token. The token, so if the token literal is not null, unexpected percentage s, and we give it also the value. So we say this thing, else we just have to print the token type. Then if we have a file name, it's the same thing but with the file name. I think this error is parser show error is fine now. It shows lexical errors and syntax errors, like syntactical errors. It shows you unexpected tokens, right? That's what I wanted to have here. Maybe I don't, the only like the only ick that I have with the parser is that it needs the characters from the lexer stage. It's like weird to need that. But maybe we can enrich the tokens with the line and column, because I mean we can still keep the position but also add the line and column or something like that. Why not? So yeah, like why not, right? Unsigned int line and column, basically, right? So now if you go inside of lexer.c, when we do token lexer next token, we can do something like, do we have util? We don't have. Include util.h. We can have here unsigned int line column, and here we can use util post to lc and give it this thing, and then talk.line, talk.column. Excuse me, it's column. I like it column. So basically, yeah, and this fixes the issue. So now let's go back to parser.h, remove the buffer. We don't need it. It was fine. In parser.c, now we don't need a buffer here. We don't need util. We don't need this thing or this thing or this, because we have token.line. So I think it's better like this. Hopefully, I mean, let me think about it. Do we need the buffer for anything else? In the parser, I don't think so. Like we are no longer gonna need the buffer after the Lexer stage. So why keep it then, right? And I think, yeah, we actually don't need it, because we can have, like, error messages will be, based on the line and column inside of the tokens. So yeah, we don't need it. Even the error messages will be like including the stuff from inside of here, so inside of the token, so we don't need it. Let's delete that, and yeah, now it's a bit more less icky for my taste. I mean, the function is huge, but it should do the job. So let's see. Let's continue with the stuff. So basically, when we return defer, we have to recover so if parsing an attribute fails for some reason, right? If it fails, oh, it does recovery here. So can we? No, we cannot really. I was thinking, let's get the current token, get the current token and show the message here. But yeah, let's not try that. Maybe an idea is, so let's say if it fails, right? So the token has some value inside of it which is useful. So this needs to be current. And here we advance, right? So in the defer section, we can actually, so if result is not 0, we can show the error. And how about doing recovery here? Like that can work to do recovery in the same function that failed. So basically, the function either gives you an attribute or moves you into a position to continue parsing. Like it doesn't block you basically. So let's see, inside of this, it tries to parse an attribute, it fails, so it will get the current token, and it doesn't need to do any recovery. How about that? I think that sounds good to me in some way. So how about, so we do parser show error. Oh, that's strange because it takes the current one. That's nice. So you don't even need to specify the token, it just gets it. And then how about parser recovery? So it shows the error and then it tries to recover and go on the thing that's after the semicolon if the result is non-zero, and after that it just propagates the result, whatever that is. Okay, so here we need to take the current token and then parser advance. After the class name, we advance. Then we have to handle the initial value, which is optional, and it's going to be an expression, so that's difficult. We leave it out for now. Then, since we are already advanced, we need to take the current one, and if it's not semicolon, it's an error, otherwise we just advance. So that should leave us in a good state with parsing attributes, basically. Now let's see the class. So first we take the current token. If it's not class, we are gonna show the error and recover. So that's one thing. If it was class, we advance. Then again, we take the current token and we advance. If it's class name, advance just moves forward, so doesn't override the token. Okay, so if it's class name, we initialize basically the the class node with the name, the position. Yeah, here for position, maybe we want the line and the column instead of pose. Let's think about it. We want also the line and the column or pose. We want the line and we want the column, I think, for the node info. I don't know about position. So we take the value, the line, and the column. I think we no longer care about position at this point. Like, even if you have a text editor, you just care about line and column at this point. So yeah, let's say line and column. So here it's gonna complain, obviously. So we're gonna say line, token line, and column. Well, again, I said column. Okay, so we have this pretty good. Here we say again line and column. So we initialize the class name of the current node. The superclass will be null for now, and we just initialize the array to be empty, but allocated or whatever, like initialized. Then we need to take the current token, and if it's inherits, then we can advance. So we move out from it. Then we need to take again the current token, and if it's not class name, then it's bad, it's not good. So we go to show the error. Then if it was a class, we have to initialize the superclass with line and column, token.column. Okay, and after that we advance on the next token after the class name. So here we need to take the current one, check if it's L-brace. If it's not L-brace, it's a problem. We advance, then we take the current token. If the current token, or better said, while the current token, or like while the token is not closing squarely brace, then we can parse an attribute. Like we parse the attribute, we are moved after the entire attribute, like after the semicolon, we add the attribute inside of this thing. Okay. If we had an error while reading the attribute, oh my god, here it's like, if we had an error while reading the attribute though, we already handled it. So we don't really need to do anything. We are gonna be on a good position, I think, right? We are gonna be on a good position to try to read another one. But we save the result because, okay, so basically here, when we take the result, we have to do something like result or the result of the function call, because we want to keep the result as 1 if it's already been 1 to indicate that it was an error in parsing. So yeah, like we take the current one, then while it's not closing the curly brace, we just try to read the attributes. Always the attribute will read until the semicolon, so it's always gonna be fine. Then we add the attribute to the list. We need to take the current one to check if it's closing brace again. And after that, we need to advance, right? So we are on top of right brace, so we have to advance the right brace to the next one. And here we need to take the current token. So if it's semicolon, we advance, and otherwise here we need to show an error. Well, not really. We should show error and recover only, like for example in this one, right? Like here, yeah, sure, we need to show the error that it wasn't an identifier, it was something else, and then recover. But in the case of a class, it's the same for this thing or this thing. But if the error comes from somewhere like here, and we actually managed to finish the parsing of whatever this was, or was it the class? Yeah, it was the class. We managed to finish the parsing of the class, but the error was somewhere else. We don't really want to, let's say, show the error. So only if it was from a return differ we want to show the error. If it was because of this, we don't really want to show it. So maybe we want to keep a separate variable for this. Maybe have an int feature result or something, and keep the feature result inside of this. Maybe that's a way to do it. And then he returned the combination of them. Though, I mean, it feels a bit strange to do it. Like, I would rather just put everything. No, I mean, it's better to have it here. But like, I don't know, it feels weird. We actually need this to be here though. Feature result. Like, just to know that parsing failed, right? Well, another thing is, let's say we don't take this into account. We don't take the error into account. And whenever we do something like parser show error, we also set the error flag or something. Like let's put on the parser an int result, and let's go into parser.h and maybe have an enum parser result, parser okay or error. And yeah, I mean, when we initialize, we set the parser result to okay, and afterwards, for example, if we call to parser show error, we have to set the let's say parser dot result equals parser error, and here at the bottom when we do this stuff, let's say result should be parser okay. So yeah, now we keep the result in here, so it's whatever. And if we do parser show error, we set the error to 2. I mean, we can do it in a separate place because maybe you want to show error just randomly and whatever, and that messes with the state, but whatever. So we have advanced. Now in parser attribute, basically, even though we return something here, it's more like doing it for this stuff, for showing the error and setting the result to 1, basically to failed, and to do recovery. But we don't really care about the fact that this failed, in fact. So here, even if it, where was it? Even if this fails, like we don't fail parsing the class yet. We would maybe, yeah, I don't know. Like we still have to check stuff like, well, it's not ident and stuff, cannot semicolon. I mean, this cannot really be bad. But for example here, if we find the end, then that's an error. Like if we find the if we try to parse an attribute and the first token is like end, then it's gonna fail directly. It's gonna try to recover, but it's not gonna be able to do that because of this. And when it's gonna return, it's gonna return on the end token, right? Yeah, it's gonna return on the end token. So in class, after parsing the attribute, it's gonna be on end. So this is gonna loop forever. But it's like the only place where that can happen. Anywhere else you would have end, then it would just fail on this. Oh, it was an end, so it fails. But here, since it's like optional to have stuff inside, we still need to check that though. But how? So it should be maybe if token type equals end, we do return defer 1. It's like an error if we found end inside of this body. Then we advance, semicolon, and here we show the error. I think that works. So let's see when we parse the program, that's fine. So this thing shouldn't have that. And here we initialize the parser. And then we parse the program. But again, we don't care about this result. We care about the parser result. So I think that's how we have to do it. I think that's that. And let's move this stuff somewhere else. Let's have maybe parse tree st view st view.h or ast print.h or print st. Well, this should probably go in print st.c file, and I mean, sure, we still need to do is print st.h and have something like def print st. We define it, indent. Let's do like this, end if, and let's end if that. So these functions are not used. Wait, what? Oh, it's what? Don't get it. Okay, so here we also need to include parser for this stuff. So I think that's everything. And now we can actually redefine this from outside to whatever we need for parser print, for identifier, like ident size. So let's include print st, and we also need stdio. I think that's all we need. No, yeah. That's everything. And in main C, let's include print ast. And now in parser, we can remove this part with parser print or whatever. So let's go back to st. So this should be print st maybe. Print st. Okay, and in main we still have it. Should be somewhere like print st. So yeah, basically the idea is we do lexer tokenize. If we have the lex flag, we show the lexer and we exit. We show the lexer result and we exit. Then we do parser, so we parse the tokens. If the parser fails, we stop and show the errors along the way, of course. And if the parser was fine, the parsing was fine, we print the ast. So maybe instead of syntactic stuff, we should say ast or something. But anyway, this is the thing for now. So let's go back to parser run. I think everything is still working. Let's go C. Let's do a make. Now let's try to look again at what was it? Parser 01. Let's try to see if this thing still works. So this thing still works. And this thing still works again. So that's good. yeah, let's change this. So this should become ast show the parsed st, whatever, show the parsed st, show the lex tokens. I think that's pretty good. So now that's lex, this should be st. Okay, fair enough. If the ast flag is set, then display the ast. Okay, so now let's go inside of the checker. Just fix it before we add too much stuff. So that's st, and we also have the checker from here. So here should be st. This should also be st. Well, I mean, we will have syntax. Well, it is syntax analysis, but it's more like, I don't know. It's more like the AST, whatever. Well, it was fine to be called syntax analysis, I guess. Let's leave it whatever. Doesn't matter. Doesn't really matter because it's more like, well, it is in fact syntactic analysis. Okay, so whatever. Let's make. Let's try again. The only thing we might need to change is here. Oh, run is fine. So if we go here and do cool C, and here we try to run it on the first one with the lexer, this should give us the tokens, and syntax should give us the AST. Yeah, that's good. Okay, anyway, let's disregard that tangent and go to parser run. So inside of parsing the class, or I guess the next thing would be, okay, was the third? The third one is actually doing the init. Well, that's not that bad. Let's do a commit first, or at least have like did some stuff on st whatever, and here we have the optional initializing, right? So that's like parser, we take the current one. If the token type is a sign, right? If we encounter an assign, it should be similar to inherits. We have to advance, right? We have to advance because it's the assign symbol. Then we need to check this out. Am I blind? Oh, it's this one. Then we need to do an expression. So we need to do this entire stuff, which sucks. But Let's try it. So we find an assign, we have to advance, and here we need to do well, I don't really like that this is also called parser and this is also called parser, the syntax. But we can't really do anything about it. It is what it is, it isn't what it isn't. We have to deal with it. Maybe it's more like parse attribute, you know, or like visit attribute. If you know the well, I like the visit idea, or maybe build attribute. Let's say it's build attribute, just so it has a different name than parser. So this would be build class, and the last one should be build program. So now when you look at it, you see like build program is just building classes. Oh yeah, and the last thing, for a program, we don't care about the result, and here we don't want to do recovery because we already did recovery in here. So we take the result, we return it, and that's it. I mean, you can't really fail on program. Like fail with what? Wait a second. I mean, if the program is empty, yeah, I mean, if the program is empty, then it's considered a fail, I guess. So we can have something more like parser current at the start. Though it's gonna fail on this, right? It's gonna fail, it's gonna try to recover, it's not gonna be able, blah blah blah. And it gets here and it exits. Fine. So it's not really a big issue. But like, yeah, sure, we could do a while loop and not even attempt to parse a class if the first one is end, because it's not gonna work. Would it make more sense, or does it make more sense to have it like this, a do while, because of how this looks? I have no freaking idea, mate. I think this is good enough. Let's not get paralyzed by the analysis problem. So, oh, yeah, obviously we have to go in parser.h, and for attribute node, we have an optional. Oh no, we need an expression node. But what's that gonna be? It can be like so many things. Well, yeah, here comes the problem. How are we gonna do expressions? Because expressions can be cases, for example, or like, yeah, case, or it can be an if statement. So like here we need a void pointer inside of attribute. That kind of sucks. But I mean, for now, let's just do node info init, so uh, optional, and we assume it is gonna be a string, like just a single value. It's not gonna be an expression for now. So let's do here build expression static int build expr. So what's it's gonna be? Struct parser pointer parser, and I mean, we actually need the type def struct expr node, and it's gonna be just a value. So let's do expr node, because we don't really know. We assume it's gonna be a string or whatever. It's gonna be just a single thing. So for building an expression, we need expr node expression, and pretty much let's do something like expression. Wait a second, I want to check in here. Here we didn't really need to parse anything, and, for that either. Just for attributes, and we did append. I was just thinking, where was it? Why not just, like, why do we need to do expression like this? Why not just do something like, well, let's leave it. We can do this and do build expression, right? And it advances us after the expression, like on the semicolon. But if editing the expression fails, I don't know how to handle it. Like, if reading the expression fails, we're gonna do what? I'm not sure yet. So yeah, like here we have this expr, but we can use the attribute expression directly. So we can do something like attribute, and I forgot what was it. Oh, init. Let's call it expr. So we can build directly into it. Like that. And I mean, yeah, who knows? How are we gonna handle it? Probably it's a good idea to use a void pointer here for expression, and then maybe an enum for what it's actually there, like the expression type. I mean, for now, that's the only thing, right? Like for the fourth test, what's that? It's method. Yeah, I mean, I guess we can leave it here for now, and I just have to think about how to handle the expressions then. And also, like, if you fail on doing an expression, it's gonna read until semicolon, so this thing is not really gonna work. So actually, like, the return code here matters a bit. If it's like, if you fail, then you just go straight to defer or something. Something like that. Though you, or maybe you can just directly return. Like if building the expression fails, yeah, it's not good. I mean that this test is not really hard, so we can actually just try to do this first and not deal with node expression. So it's gonna be like value. So let's take expression and leave it out for now. And for this test, like here is gonna be to do fix this, but it's just gonna be, we take the current token. If token type is not equal to int literal, we fail, right? We fail, and otherwise we just set the value, the line, and the column. So I think this should make sense for the third test. So let's see, third test. Yes, I think so. Let's just see the reference. So it also shows the value if it's there for attributes. Okay, so let's go to print st. So, well, let's do a separate static void attribute print, and it's gonna be an attribute node like this. And here we print the attribute, and if it has a value, we show that value. So now if we print this, we have to initialize with so if it's not an assign, like here, we do fix this. I mean, we don't even need to do comments, but attribute value equals null, so it's not gonna show it. That's the point. So now if we check her, we should get the third one as well. So yeah, I mean, what's like next to do, I guess, is to figure out a good way to keep the values. I think using a void pointer and an enum for the type, it's gonna be best. Like the type is gonna be one of these, and the void pointer is gonna be to a structure. So maybe something like, or like we are gonna have an expression, so something like this, and the expression is gonna have a void pointer expr and an enum expr type. Maybe this is here type. Maybe this is better. Right, I think this could work. So basically, yeah, I think this is how I'm gonna try to do it. And yeah, I mean, we still have functions to do, so that's gonna be easy. But then the expressions. So yeah. Yeah, and in the results, we got the first three, and if we do the Lexer, we got all of them. So yeah, the stuff is decent. Let's see, I'm curious before we end this. Let's do cool see. So this gets the right result, and if we try to do for 04, we get unexpected L parenthesis, which is nice because parser 04, it's like, oh, I don't know why there is parentheses. I thought F should be an attribute, so I don't know how to handle this. And then again on G. So yeah, it's actually so far so good, I guess. We got some working. So I guess yeah. Now I'm pretty much done for today. I mean a longer one, but we got some stuff done. So next time.